Okay, so in this video, we are going to take a look at piecewise functions. So the first thing we're going to look at is how to write the equation of a piecewise function from a graph. So for this first example, let's just call this example 1. We're going to write each piece of this graph in what we call a piecewise function notation. So we're going to call this f of x equals, and then we set up a big curly brace to include everything we need here. So let's first look at this red line. It is a horizontal line at y equals -2. So at that line, y equals -2, f of x is like your y. So you already said y equals, you just have to write the -2 over here. And then you look at where's that piece located? So it's located at -3, and then it goes toward infinity. So we're going to say it's for all the values of x that are less than or equal to -3. Then let's look at the blue piece of our graph. So that one is a line, and it's just a piece of a line. So we can tell that our y-intercept is at 1, 2, 3, 4, and it has a slope of -1. We can kind of tell that it goes down, and it's just going by one box at a time. So it has a slope of -1 and a y-intercept of 4. So it's that equation, y equals -x plus 4. You don't have to continue to write y equals because it's already written when you put the f of x over there to the left. And now it's only this piece of our graph. So we go from -3 to 0, and notice those are open circles. So it doesn't claim that part of what we call a fence. We'll talk about that in a minute. So we would say this is for values of x that are greater than -3, but not equal to -3, and are less than 0. But again, not equal to 0 because the hole is open right there. And then let's look at this green piece of the graph. So it has a y-intercept of 0, and then we can tell it has a slope of 1. So that is just x. We don't have to write the y-intercept of 0. And then that piece of our graph goes from 0 to infinity because it includes all the values of x past that. So we would say that is for values of x that are greater than or equal to 0. So that's our piecewise function that represents this graph. Let's do another one. So number 2, let's start with our red piece of our graph, and we'll set up f of x, we'll just use that again, equals, and make a big curly brace, we call it. So this is another horizontal line, so that's at y equals, and notice these boxes are worth 2 on this scale. So that would be -2, -4 is where that one's located. And then it goes from 0, and it's equal to 0, and then it goes toward -infinity. So we would say that's for all the values of x that are less than or equal to 0. And then this little blue piece of the graph right here looks like it has a y-intercept of 1, and then it looks like it has a slope of, let's say, 2/2, which is equal to 1. So if it has a slope of 1 and a y-intercept of 1, we'd say x plus 1 would be our function. And then it goes from 0, but it's not equal to 0, and it goes toward all the positive values of x. So we would just say that is the piece that is at x is greater than 0. So now we've written our 2 functions from our graphs. Now let's look at how to graph them. All right, so graphing piecewise functions takes a couple steps. First, we're going to draw dotted vertical lines where the domain is separated, and we call these fences. So look over here at this example. Your fence is where you can kind of see that the values are going to go different ways. The 1 would be our fence in this case. So let's go ahead and draw a fence at x equals 1. That's what that first step is talking about. That is our fence, we call it, because we can tell that's where it's going to not go the same way. Create a table of values on each side of the fence using the appropriate equation. So where x is less than or equal to 1 is over on this side of the fence, so I'm going to put x plus 2 over here. And then 4 is where x is greater than 1, so I'm just going to stick that on that side for now. So they're on the appropriate side of the fence. So if x plus 2 is my function, that's y equals x plus 2. Remember that. We're going to plug in some values of x, and our y value will be x plus 2. And we don't need a whole bunch of values because that's just a line. So let's just try -2, -1, and 0. So -2 plus 2 is 0. -1 plus 2 is 1. And 0 plus 2 is 2. And then we're just going to plot those points because that's our next step in our process here. So plot the points from your table of values and connect with a smooth line or curve. So we're just going to plot a couple of points like -2, 0, -1, 1, and 0, 2. So then we can tell that there's going to be a point on that fence, but check to see if it claims the fence. So if x is less than or equal to 1, then this piece of our graph claims the fence. That is what we call claiming the fence because it's equal to the 1. And so then we have this little piece of our graph, and it's going to continue in that direction. Now 4 is the only thing that was on the other side, so if y equals 4, because that's basically what this means, f of x equals 4 is the same thing as y equals 4. So we go to 1, 2, 3, 4, but then it can't claim that part of the fence, because that one's already claimed it. So if y equals 4, we have to put an open circle and draw our graph going in the positive direction because x is greater than 1, but not equal to 1. And then we have graphed our piecewise function. So let's do another one of those. All right, so the first thing to do is figure out where your fences are located. So on this graph, it looks like we have a fence at -3 and 0. So let's go to 1, 2, -3 is a fence, and 0 is a fence. Now on your paper, you'd probably want to do this in pencil because they're really not part of your graph. They just help you to set up the graph. But that's a fence, we'll call it, and that's a fence because we're just taking notes right now. And then we're going to set up our table of values. So I'm going to use a couple different colors. So for x is less than -3, so over in this area, we just have 0. So I'm just going to put 0 over here. In the middle of our graph, between -3 and 0, our y equals -x. So that's -x. And then we have one more piece. Grab another color. So where x is greater than or equal to 0 would be over here. We're going to put x squared minus 1. So that's where those pieces belong. Then we just need to make a table of values. Now, 0 really doesn't need a whole table because that's really just y equals 0. And then we just see if it claims the fence or not. So it's less than -3. So it will not claim the fence. And just be a line at y equals 0. And it's going to the values less than -3. So that's part of our piecewise function over there. In the middle, we have the line y equals -x. So if we plug in, I'm just going to write it over here where I have more room, x, and then our y is equal to -x. We just need a couple values in here. So it'd be good to put in -3, -2, -1, and 0. So let's do -3, -2, -1, and 0. And then -x, because that's what our y is equal to, would be 3, 2, 1, and then 0. So we go to -3, 3. Now this one will claim the fence because right there it's equal to. So that one claims the fence because it's equal to -3. So -3, 3 claims the fence. Then -2, 2, -1, 1, we're just plotting points, and then 0, 0. Now check that 0 will not claim the fence. So that one is not equal to. So we need to put an open circle right there and draw our little piece. Now we only have one more piece left, our purple piece. So we're going to make values. Let's just move it over here where we have more room for x. And then our y will be x squared minus 1. So let's just pick a couple values. Let's say we want to pick 0 because we want to know where that one's going. And let's say 1 and 2 and see if that will help us out. So if we plug in 0 squared minus 1, that's negative 1. 1 squared is 1, minus 1 would be 0. And then 2 squared is 4, minus 1 would be 3. Then you check your fence. At 0, this one does claim the fence because it's equal to 0. So 0, negative 1 will claim the fence. And then we had 1, 0, and 2, 1, 2, 3. And we could tell this one is quadratic. We've been working on functions so far, and so we know quadratic looks like a curve. It won't just be a straight line. So that would be what our little piece in purple looks like over there. So now we have our 3 pieces of our graph. We've carefully picked out exactly where they need to go. Let's look at one more quick example. This won't take long. If you need to evaluate a piecewise function, so let's say we're given this function right here, and we have these pieces, and we have where they fall on the graph. We need to use the x value given in the function notation to decide which equation it applies to in the piecewise function. Then plug the x value into the appropriate equation. So let's see what that's talking about. So for this first example, they ask for f of negative 5. So you have to find where would that fall in these two options here. Is it less than 4 or is it between 4 and 10? So negative 5 would certainly be less than 4. So then we plug it into that part of the equation. So 2 times negative 5 plus 3 would be appropriate. And then we get negative 10 plus 3, which is just negative 7. So for f of 8, 8 would fall between 4 and 10. So in this example, x squared minus 1 would be your appropriate equation. And then you just plug 8 into that. So you get 8 squared minus 1 is 64 minus 1, which is 63. All right, so that's it for piecewise.